It's great to see all of you here. Let's have a round of applause for the 5 people who've already spoken, who've done a fantastic job today. I usually don't get terribly nervous before I come up to speak, but then when you follow a lineup like this, I mean, you know, I don't know about you, but these guys have been fantastic. So I'm going to wrap up today by talking to you about some of the things in code that I have learned can be pitfalls, and I call it the 7 deadly sins of object-oriented development. As she said about me, I have a small company. I do a lot of training. I do fly small airplanes for fun. When I wrote this, I actually had my private license. Now I've upgraded to a commercial. To answer the obvious question, no, I did not fly myself to Serbia. I do not have the $65 million to buy a Gulfstream yet. So, and if you want to reach out to me, if you want to talk to me, you want to tweet at me, you want to tell me what a jerk you think I am after this, whatever, you can get in touch with me here, my website, my email address, and my Twitter. When you have finished with this talk, and with all of the talks today, please rate them on Joined In. It's really important. It's really good feedback for us as speakers to help make the talks better, to help us to help you, and also for us to know how we're doing. You know, if something isn't clear or you just completely misconnect on a talk, please let us know, because that's important feedback for us as well as for the community to make these things better. So this is the Joined In link for my talk, but if you go to Joined In and you can click on SOLIDay, and all the talks are listed, please rate all the talks you've seen today. It will really help all of the speakers to make their talks better. All right, so what are these 7 deadly sins? These are the things that I see over and over again that I find developers make these mistakes repeatedly. So the 7 deadly sins are tight coupling, extending the interface, having too many classes, having too many responsibilities in the same class, developing overbearing interfaces, failing to actually write object-oriented code when you want to write object-oriented code, knowing too much or violating teaching your objects way too much information, and then over-abstracting your code. These are the things that I find developers do over and over again, and we'll go through each one and talk about them. So number 1, tight coupling. This is probably the most common thing I see other than violating the single responsibility principle. Tight coupling is the thing that I see over and over and over again. And we talked a little bit about this today, and I find that there are really 3 types of tight coupling that people do on a regular basis. The first kind is like this, and I realize the code's a little bit small up there, so I'll explain for those of you in the back who probably can't see that, what's happening here. I have a class, and in it I have a method that is instantiating an object. Now we learned from Rob's talk today that really what we want to do here is dependency injection. That's our goal. But beyond the injection of the dependencies or creating a dependency here, the other thing that we're doing is we're tying ourselves to the class name. And what we're doing is the class is named other class. We are now and forever tied to that class name. If we ever change it, we're going to have to change it in here. We can't mock it. We can't substitute it. We're always tied to that particular class. And the problem is that we want to tie our code to objects, not to classes. This is object-oriented programming, and objects are the things that we care about. So objects have behaviors, and objects have things that they do. Classes are just collections of code, but objects are things that in our application do something. And so that's what we're really trying to tie our application to. The second kind of tight coupling is having way too many dependencies. This is a sample controller, and I have, let's see, 1, 2, 3, 4, 5, 6, I think I count 9 dependencies there. Okay. What happens when you have this many dependencies, especially in something like a controller, is a number of things. One, this becomes impossible to test because you are going to end up mocking every single one of these. And so, I mean, that's just, you know, it's going to make you cry. It makes me cry when I have to mock something like this. But also, in a context where, for example, let's say you're developing a JSON or a REST API of some kind. Well, JSON response is not going to have a template. right? It doesn't have a template. It's just going to be some text, so you're not going to have a template. Well, I still have to inject this because this is in a base controller. So having this number of dependencies creates a number of problems. There's a reason that it's called dependency injection, because when you have dependencies, every dependency you inject ties your object to another object. It basically links them together, making them more and more difficult to separate out. We talked about code not being reusable in the last talk, which I tend to agree with because I found that tends to be very, very true. But in those rare cases where you do have something that you can use in other places, if you start tying it to other objects and expecting that those objects are always going to exist, you've just killed any chance of reuse that you ever had. A couple of things that you can try the mediator pattern if you have a lot of dependencies that do need to interface. So instead of having all of those interface with each other, you can instead have one thing that's tied to all of them, and that's its whole job. That's its whole reason for existing. This might look familiar. This tends to be how a lot of controllers tend to look, is the mediator pattern. But that's one strategy. You can also try some service location or using factories to get the dependencies that you need. But none of these are really, really great strategies. The best strategy that I've come up with for dealing with this is to ask yourself if your code is too complex. If you're injecting that many dependencies, there's a good chance that your code is just doing way, way, way too much. All right, number 3. Exposing your internal methods. And I picked this sample because it's easy to understand. It's a database example where we have a method, a public method called fetch1, and we're passing it a SQL query and an array of parameters. And then we have another method which is meant to be internal, which is the prepare method, to go ahead and prepare that SQL query so that we can use it just like PDO would expect. The problem is that based on how I've designed this, I want prepare to be internal because I don't want you to prepare the query beforehand. Now, if I make it public though, somebody eventually is going to go along and use it. And just like we were talking about in the last session, I really like that quote. I wish I'd had that before this talk because it's true. If you make a method public, you're going to support it for the rest of its life. You only want to expose methods that are required to be public. You only want to expose those methods that are part of the interface, part of the behavior that you want your application to express. If you don't want those methods to be part of that behavior, then mark them as protected or private, which you and I are going to have that out later on, protected versus private. But mark them in some way that they cannot be accessed from outside. Because if you don't, I guarantee it, someone is going to use the method that you thought no one would ever find. And then you're going to make it protected or private or remove it or change it. And somebody's going to file a bug report saying, I was expecting this to do something. And you're going to be, you're saying, well, it was internal. Well, it was public. All right. The number 2 mistake I see pretty often is that developers will extend the interface that they've designed. And this is what I mean by that. I have 2 classes here. The top one, called MyClass, has one method in it. And the bottom class extends the first one and adds a new method. Now, the use case for this is in our controller, we're passing in and we're hinting on an instance of the parent class, but we're calling the method that we defined on the child. See right here, we're calling the method that we defined on the child. The problem here is that if you ever change your code to just use the parent and not the child, it will pass a type hint, and then it will blow up with a big fatal error because the method doesn't exist. Now in Solid, the Liskov Substitution Principle says that subtypes should be identical to their parents. In other words, I should be able to take a child class and substitute it for its parent class, and it will work and behave in the same way. A good example of this might be a caching library, where you switch from APC to Memcache to Redis or whatever it is that's new and cool these days. You should be able to do that seamlessly without breaking the behavior. Your application shouldn't care. But here, it cares an awful lot. because instances of the parent class will just fail. It just won't work. It'll just break your application. And that's a really crummy thing to find out at 2 a.m. on a Saturday morning after you've gone out drinking for a few hours. Trust me. Okay, so there are some ways to fix this. There are some things you can do to avoid this from happening. The first one would be to mark the base class, the parent class, as abstract and include the abstract method. So if we've updated our code here, what we have here is the parent class is now abstract, and we've included the child method, but we don't know what our implementation is necessarily going to be, so we've marked it as abstract. And what that does is it defines that this is going to be part of our API. This is part of our contract with objects that use this. But since we don't know what the logic is going to be until later on, we're just going to leave it alone. It's up to the child then to implement that, which is what the child does. The child actually implements the behavior. So now, when I type hint on the parent and call the method that I've implemented in the child, every time I do that, it will always work because the abstract method was defined. It's part of my agreement with the object, and it's part of the contract. It will always work. That's option number one. Option number two is maybe you actually meant to create a new type of object, and that's okay. Sometimes you actually do need to extend it. There are rare valid use cases where you can extend objects, and so you actually do want to type in on the object that you've created because it is in fact different. It behaves in a different way. Not as clean, not as beautiful. It probably should have its own interface, but hey, it works. Now this will always work because we're now, instead of type hinting on the parent, we're now type hinting on the child. The parent will no longer pass PHP's type hint, but the child will. The third option would be to create two different interfaces and type hint on the interface that you want. So here I've changed these two interfaces, and I'm actually extending one interface with the other interface. You can actually do that in PHP, in case you didn't know that. You can extend an interface. You'll see this. There are a number of the iterators that do this. And then I can choose to type hint on which interface I want. Now, this gives me an interface. I can test this interface. I can use this interface in a number of ways. It doesn't implement the logic, but I am essentially establishing a contract. And that's the important thing here, is that I can expect that if I'm type hinting on this interface, every object that implements it will have this method, and that this method will work the way I expect. The thing is that objects know each other by their interfaces. They know each other by their behaviors, and those interfaces define the type of object. And I mean interface here, not necessarily just in the sense of PHP where we have interfaces capital I, where you can make an interface, but I'm talking about the public methods. So if you have a value object or you have just a one-off object that doesn't necessarily implement an interface, well, it still has one if it has any public methods. And those public methods become part of the contract that you are establishing with anyone who's planning to use that object. Defining an interface in PHP is great because that formalizes the contract for future developers. But even if you don't do that, you still have a contract and you still have an obligation to the public methods that you've defined, that they will still work, that they are reliable, that they're consistent. Okay, so number three, you have one class that has a lot of responsibilities. So I have here a sample controller. And in this sample controller, we are authenticating a user. And this, believe it or not, I've seen code that looks like this from developers who have been developing for a very long time, where they'll pull the information out of the superglobals, and they'll then connect to the database and actually write SQL in their controllers, and then do the query in the controller, and do the verification in the controller, and then move on to something else. This happens a lot. And the problem here is that I can see at least 5 different distinct responsibilities in here. I'm sure somebody smarter than me could probably come up with more, but I'm going to go with 5 for now. Now, this is a real problem because the single responsibility principle says that each object should only have one job, and it should be able to do that job completely by itself without needing any other objects. So it should be able to do the job that it's been given. So let's refactor this just a little bit. So the first thing that I'm going to get rid of is I'm going to use some kind of a request object, and I'm going to drop those globals. I'm going to let somebody else deal with that. That's the first thing that I'm going to do. And I'm going to inject, which is not shown, this context or this request object into the application, and then I'm going to use that to get the information. I'm no longer dealing with the globals. That's somebody else's job, to verify that they exist, to sanitize them, or, to do whatever it is that I expect. I'm going to give that job to someone else. The other thing that I'm going to do is I'm going to drop this crap about doing the SQL query in here. I'm going to give that to another object, which I'm going to call the user model, and I'm going to instantiate that, and I'm going to give it a connection, and I'm going to pass in a configuration for it, and then I'm going to tell it to do the authentication, and I'm even going to let it handle the password verification. So all it gives me is a user, and I realize I'm breaking the mixed type here, because if either I'm going to get a user or I'm going to get a false. I'll fix that slide for the next time I give this talk. But for now, that's what we're going to live with. So we've now eliminated those responsibilities. But there's still a problem with what we've done here. The problem is that we're instantiating the object, and we're actually taking the time to configure it. We're actually instantiating two new objects here. And the problem is that object creation is a responsibility. So essentially, I've given this a new responsibility. I've said to it, I'm going to take a bunch of responsibilities away from you, but now I'm going to add one. So I still at least have two responsibilities in this controller. So instead of doing that, what I want to do is I want to use dependency injection, which we learned about earlier today. I can also use a factory if I really need to use a factory, but I'm going to use dependency injection here to manage these dependencies. And instead of instantiating them, I'm going to assume they're just passed in for me. And now I can eliminate that responsibility. I don't have to worry about it anymore. So now this code is considerably cleaner. I've done a good refactor on it. It looks a lot better than it did. And the only thing this does is it does a logic switch between whether or not the user actually authenticated or whether or not the user failed to authenticate. All the other work is done by other things that's their job. Now, I make some exceptions to this. I will create objects locally if I need them. So date time, for example, I would generally create locally. This is where we disagree. And for me, there's no need to inject a paginator. Your mileage may vary. You may run into some problems with this approach, but for me, this has worked, and that's my exception to the rule. So even though I would generally inject everything, there may be some cases when I don't do that, but they're very few and far between. Number 4, the overbearing interface. I have a very common database interface here. It has 6 methods. A connect method, a query method, a prepare method, and then the transaction methods that you'd expect on any database object. But there's a problem here because not all databases support transactions. And in fact, a lot of the NoSQL databases don't support them at all. So this would not work at all for that. So the problem is that for those that don't support transactions, they're going to have empty methods for those transactions, or they're going to throw a bad method or a not implemented exception or something like that if you call them. Now, the interface segregation principle says that we shouldn't do that objects should not have to implement methods that they don't use, that their interfaces should be small and compact enough that they only implement the methods that they actually need. Well, there's a solution to this problem, which is to break this into 2 interfaces instead of just 1. The first interface would be the database interface that would have all of the typical database methods: connect, prepare, query. And then the second one would be an extension of that, which would be transaction-aware database that would implement those transaction methods. And those transaction methods would then be available for us to use as we need them. The goal here is that if you rely on those transactions, you can require the transaction-aware database method and ensure that those are always available, and ensure that when you call them, you don't get a bad method exception. The other side of this coin, though, is the concept of the God object. Who here has ever seen or implemented a God object before, by mistake or on purpose? So On purpose? Yeah, okay. The concept comes out of a story from Xerox a long time ago. I'm sure everyone has heard of Xerox. They make photocopiers. And back when we actually cared about how much memory something was using, they were developing a new copier that would do all kinds of great stuff. It would fax and collate and staple and duplex and all the stuff that a copier does, some of which nobody ever cares about, but it's still part of the sales literature, right? And they were discovering that every time they added new functionality to the copier, it took longer and longer and longer, on the order of exponentially, for it to do anything. And so Xerox did what all good American software companies do. When they had a problem that they couldn't solve, they hired a consultant. And the consultant came in, and the consultant sat down with them, and he took a look at their code, and he said, well, I see your problem here. The problem was that they kept adding all of the behavior to one object. Okay, so one object kept getting longer and longer and longer. Well, the problem here is that if processing time is really, really limited and your objects are really, really big and memory intensive, of course, your application slows down. And again, we're talking like 16 kilobytes of memory here rather than megabytes or gigabytes. So what he suggested was that they break this into smaller objects and have an object whose job it was kind of to manage this process. And Xerox was happy, and they shipped their copier. Processing time dropped dramatically, and this guy went off to invent this principle that I'm describing to you now. Well, there are some examples of God objects even in PHP core. Anybody in here use Imagic before? Okay. This is the interface for Imagic. This is also the interface for Imagic. A third slide. And a fourth, and we're like up to G, okay? If I was to do this, I think I calculated it out, it would take something like 63 slides. I got bored after about slide 1, and I basically just started copying the documentation, and I didn't even care that this isn't valid PHP because I just didn't care anymore. Because the point is made by this point, and your eyes have probably glazed over, and no one is going to notice that that's not valid PHP. It's actually the documentation that I copied. The bottom line here is that small interfaces are best. The smaller the interface, the better off it's going to be. The easier it will be to test. If you're testing every code path and your interface has 18 methods and each method throws 2 exceptions, well, congratulations, you've just decided that you're going to write 18 times 3 tests just to test that one interface. Okay. So small interfaces are a good thing. The smaller they are, the better off you'll be. Number 5, failing to actually write object-oriented code. There are a number of libraries in PHP that make things easier for you that a lot of people don't use, and I don't understand why, but we're going to talk about it. Globals, for example, have absolutely no place in object-oriented code. This is a solved problem. There are request libraries. Symfony has one, Zend has one, Aura PHP has one, Laravel has one, CodeIgniter probably has one, and I don't think that's been updated in a while. So this should never happen. I don't want to see this in code anymore. Please stop doing this. Use some kind of a context object to do this instead. Let someone else manage this process. And the reason for this is that this is now testable. I can actually write a test, and I can mock the Aura web context, which is what I use. And I can give it values and tell it how many times to expect it, and then I can write a test and verify that it works. And I can put good data, I can put bad data, I can do anything that I want to test this. I can test all the paths that go through it. Globals, much harder to test. And so I can test this. This is testable. Similarly, there are other cases where you have procedural libraries in PHP that already have object-oriented things that are, let me start that over. There are procedural libraries in PHP in the core that people have written object-oriented wrappers for. There are others that actually have object-oriented wrappers in core. For example, date time. All the date stuff is both procedural and object-oriented in PHP. But other things like file uploads, not so much. So people have written libraries for this. Again, with the globals, underscore files global, super global array, let's move away from that. There are libraries that can do this for you, where you pass in an object and you say, this object is responsible for doing the uploading for me. Because I can test this. But more importantly than testing this, I can do other things. For example, if I have move file or move uploaded file, I'm always moving it to the local file system. But if I use an object whose job it is to do that, I can configure it to use Amazon. Or I can configure it to store it on some CDN. I can do a lot of different things with that file based on the needs that I have and as my application grows, without having to rewrite a tremendous amount of my code, because that becomes configurable. Or I can change the backend. I can plug in a different backend. And it also allows us to mock the file system when it comes to testing. And who's ever written a unit test for file system uploads before? It was painful, right? It's a lot less painful when you can actually just mock the thing, mock the file system, have it go to dev null. The goal of being a programmer is not to write as much code as you can, it's to solve problems. And so I make it my personal philosophy to write as little code as possible, because there is so much code available on Packagist and in Composer and with libraries that are available today that I don't have to write everything myself. There are a lot of smart people who write libraries that I can use to my benefit to get things done, and I don't have to reinvent the wheel. So this is a sample of my default Composer file from, I think, actually last year. But I've got some Zen framework stuff in here. I've got Monologue. I've got Whoops, which I've actually replaced with a library that I wrote called Boo Boo. I've got the PHP Leaks Fly system. I've got a lot of Aura. All of this stuff I can just grab, and I basically have created myself a little set of packages that do a lot of cool things that I don't have to do now because someone else already took the time to do the work. And by the way, as an aside, if you're using a library that you really, really like, please thank the person who created that library. They probably don't hear that enough. And open source libraries are the core of what makes the community work and makes many of our jobs easier. So please make sure you thank those people. Wrapping procedural code in a class does not make the code object-oriented. It will still be procedural code. It will just be class-based procedural code. To really write object-oriented applications, you have to think and behave in an object-oriented way. The sixth thing that I see a lot is that people teach their objects way more than they should. For example, they do this. This is not a fluent interface. This is me calling an object that then calls a method, that then calls some other method, that calls some other method, actually calls some other object, that calls another method. I'm chaining calls together here. And what I'm doing is I'm violating a principle known as the law of Demeter. The law of Demeter, and this is really the only bullet slide I have because I couldn't figure out how to explain this without a bullet slide, is the concept that every unit should have limited knowledge of all the other units. Your object should not know 16 layers deep in your application. They should really only talk to their friends instead of talking to strangers. And within that context, they should really only talk to their immediate friends. That means objects that they have been given to do a particular job. It's okay to write helper functions along the way to do things. So it's okay to do something like this, where you call your property or your object that was injected and you tell it to do something. That object then tells the object it knows to do something, and on down the chain we go. That's cool. The reason that we do this is that we want to make sure that we're only talking to the objects we know, and that this makes it easier to test, it makes it easier to maintain, and changes way down the stream don't break our application today. Number 7, over-abstraction. I said this once before, I'll say it again. Our main job as software developers is to solve problems. Our job is not to write code. That's not what we get paid for. Nobody pays me to write code for them. They pay me to solve whatever business problem that they have. And if that involves writing code, great. But if it doesn't involve writing code, they're just as happy to have their business problem go away. They're cool with that. I see a lot of times people get trapped in this cycle where they think, okay, well, I'm going to write this thing, but I have to think about this potential situation 5 years from now and this potential thing over here, and there might be a case where I'm going to do X, Y, and Z. So I have to write this big framework to do one small thing. The reality is that that's not necessarily true, because at the end of the day, you can always come back and refactor. If you find a use case in a year or 2 years, you can come back and refactor your code. Of course, this assumes that you've got some tests. But if you have tests, you can refactor this, you can change it, you can abstract it a little bit further. And at the end of the day, if you never have to revisit this code, great. Now you have something that works for the client that may not be perfect, but it works, it gets the job done. But when you come back to refactor, if you have tests, it's possible to do, and you don't have to worry too much about it. And on that note, you do have tests, right? This is Chris Harges. He's known as Grumpy Programmer. If you don't have tests, he just shakes his head at you and looks sad. He loves testing. And testing is really important. You guys had a conference on that last year, I think, yes? Yeah. So all of you should be writing tests, right? Yeah. Okay. I wrote a book a while ago on object-oriented programming, which I want to share with you at Discount Code, which is the name of the conference, which also expires on the 15th. And it's Mastering Object-Oriented PHP. It's available at masteringobject-orientedphp.com. It looks like I finished a little bit earlier than expected, but that's probably good since we're running a little bit late. But with that, I'll leave the slide up here while I take your questions. No questions? Crystal clear? All right, well then I can turn this over to whoever's